Internally equalized TXV. These are a TXV, and you can see the picture of it on page 490 at the bottom. It has that extra external equalizing tube going to the suction line, and you can see next to the metering bulb. And what this does is also uses the pressure of the suction line to make a decision on how much refrigerant goes through the system. I'm not sure one versus the other, but I know most of the systems nowadays come with this line, and usually it's a mechanical connection. It's on a little a flared nut that you screw onto a flared fitting on the system. There's been more problems with these than not, but they're very good when it comes to economy. So more and more putting them on just so they can get their units past inspectors and city and state code enforcement. So they're better for the system, but they are problematic. Here's the internally equalizing TXV, and this unit is used primarily, this type of thermal expansion valve is so you can adjust the system using superheat, which again, as I said before, this is much more accurate than subcooling. But again, you have this one specific type, and you'd have to figure out if you have it before you make that determination to use superheat rather than subcooling. In most cases, it's just better to use subcooling because it's already outside. You don't have to go in the attic or anywhere difficult to test this information to make sure you can do it. You can try using it, and normally I use my digital gauge that gives me a superheat and a subcooling at the same time. And if they're both equal, I know that it's charged well. If one's way off from the other, then I have to look further into it. But we'll go over that at another time. I'm sorry to say this, but I'm really not sure if I've ever dealt with a bleed valve. I have dealt with bleed ports, but the bleed valve is something I don't see a lot, or you don't see a lot on residential systems, and that's most of my experience. I've worked on commercial, but 1/10 of my time has been on commercial systems. The rest have been on residential. And the bleed ports are usually very common. And this is the idea behind pedaling that we talked about before, about pedaling that bike uphill. It's so much easier if you get a running start before you hit a hill on a bicycle. Well, what the bleed port does is it equalizes the pressure between the high and low side, so when the compressor starts, it's not pumping it uphill. It's pumping it on a nice level ground. And most units have that. Liquid charge sensing bulb. That bulb on the thermal expansion bulb, again, you could look at the picture on 490, it has refrigerant charged inside of it. So the refrigerant reacts inside that little sealed system that's on that TXV. That way it's a more accurate representation of the temperature of the coil, and it works better. But again, if you leak the refrigerant out, or you can usually tell, you'll get that bulb and you'll rub it, and it's that oily refrigerant. It's not water. You know that unit's not working properly. And I don't know if I've ever seen this, and I'm sure I have, that you can put other items, other liquids inside the sensing bulb to tweak it to make it better for your system. I've never seen any information on a unit that would tell me they've done this, but I'm sure I have. I just did not notice it. But this is something you can look for in the future. Here's a comparison liquid chart and cross-charge sensing bulb. It shows you the difference in which one to use, and it's not you're going to use it. You're going to use the unit, the system that is developed by the manufacturer. They know what they're doing when it comes to this, but this can change the amount of refrigerant put in or slowed from going in on a TXV. Gas charge sensing bulbs uses the same refrigerant as the system. This is the majority of the items are like this. All liquid is vaporized at predetermined temperatures, valve at fully open. They know how far that valve will open, and that's what they charge it to, so it's balanced. additional heat does not significantly increase the pressure. It's at a point where you get to max, and that's where max at. It won't go so far over that the system doesn't work. As I mentioned before, your main problem with these is that they do not have any charge in them, which means that piston will shut inside the TXV because you have very high head pressure, and to the point that if you don't have a high pressure shutoff switch, that you can ruin the compressor in a short amount of time. The cross-charge sensing bulb information. Again, I'm not sure if you'll ever see one, and if you do, you won't know it. So unless you look at the specifics on the design of the unit. Absorption gas cross-charge sensing bulbs. A little bit more information. I don't plan on having test questions that go into this depth, but it's good to know just in case. Sensing bulb mounting. Very important section for this. It's important that it's placed right. And you can see on page 488 and 489, these pictures are a lot easier to see. If you do not place this bulb in the right spot, you do not want it to read the temperature of the little bit of liquid passing at the bottom. You want it to read the temperature of the vapor. These have to be strapped tightly, and they should be insulated. I found the best way to do it, and it's not what they talk about in the book. I don't like strapping it down directly to the pipe unless the pipe has a small divot for it to go in, because it will move. I used to take, I think the best way to do it is take electrical tape, set it on the top of the pipe where you want it, or the side that you want it on, tape it on tightly, and then use a clamp over that to hold it there. The reason why I feel uncomfortable of tightening a copper clamp to this copper pipe is if it ever loosens up, it's going to rub and cause a leak. Where I think if you're taping it down, you give that little bit of padding in between. And then I always insulated it, even if it was inside the case or outside the case, I always insulated it well.